Hey there, and welcome. Today, we're unpacking a seriously fascinating question from the world of electrical engineering. If you've ever paid close attention to high voltage equipment, or, just been mesmerized by the raw power of electricity, you've probably noticed a very specific thing that happens when things go a little haywire. We're going to break down exactly what goes on when electricity escapes its intended path and puts on a totally spectacular, brilliantly colored light show.
Section 1. The Blue Spark Mystery.
Okay, let's dive into this. Anyone who works in the electrical field, or honestly, anyone who's just fallen down a YouTube rabbit hole of power line flashovers, has probably noticed a very distinct pattern. Why is the electric arc almost universally blue? I mean, think about it. Whether it's a massive flashover on a high-tension line, a slow-mo clip you found online, or just a quick Google image search for electrical arc, that striking blue color is practically always there. So where does this blue actually come from? What's the real technical reason behind this specific color? Well, today, we're going to map out the exact physical process that creates this vivid visual signature. And believe it or not, it all starts with the totally invisible space right in front of us.
Section 2. Air, insulator to conductor.
So we all know that under normal everyday conditions, air is a fantastic insulator. It's kind of like a giant invisible rubber wall. It safely keeps electricity trapped inside wires and definitely doesn't let current just jump across your living room. But an electric arc is exactly that. It's electric current literally passing through the open air itself. For that crazy jump to happen, a very specific condition has to be met that essentially flips a switch. It transforms that safe, invisible insulator into a volatile, highly conductive path. And this radically transformed state, it's known as ionized air. Let's look at how this actually builds up.
Section 3. The Violent Ionization Process.
Let's walk step by step through what goes down at a microscopic level to trigger this. Step 1. A massive amount of high voltage gets applied to a system. This creates an incredibly strong electric field in the surrounding area. Then step 2. This electric field becomes so intense that it actually forces the normally peaceful air molecules to aggressively collide with one another. I mean, they are just repeatedly crashing together under immense electrical stress. And finally, step 3. All these violent molecular collisions cause the air to become completely ionized. And this brilliantly illustrates the tipping point of our electrical mystery. You see, this newly ionized state is the exact physical condition required for electric current to suddenly break out of its copper cage and travel completely freely through the space between conductors. The air itself has literally become the wire. The insulator is officially a conductor, and current is now actively flowing right through the atmosphere.
Section 4. Extreme Heat and Plasma.
Now, when this electrical current flows freely through the air like that, it releases a truly staggering amount of energy. We are talking about an instant, incredibly violent temperature spike. The heat generated in this localized area immediately skyrockets to anywhere from 5,000 to 20,000 degrees Celsius. To put that into perspective for a second, that is up to nearly 4 times hotter than the surface of the sun. Just let that sink in. That extreme heat is happening right there in the open air, all because of the energy released by the current traveling through that ionized pathway.
Now, what's really interesting about this slide is what that extreme heat actually produces. When energy gets released at these intensely high temperatures, again up to 20,000 degrees, a completely new state of matter forms. The surrounding gas turns into plasma. And right here is the ultimate answer to our whole mystery. This newly created plasma inherently emits light, and crucially, it specifically emits light in the blue and violet spectrums. So, the crucial point is that the bright flash we witness, it isn't just raw electricity itself that we're seeing. It's actually the direct result of a physical chain reaction. It's the combination of the gas ionization, which allows the current to travel in the first place, multiplied by that extreme heat release, which ultimately results in this glowing blue and violet plasma arc. That stunning blue color is literally the visual signature of thousands of degrees of heat interacting with ionized gas. To wrap up this explainer, you really just need to link these 3 critical concepts together. First, the air must become ionized to act as a conductor. Second, this flow of electricity instantly triggers a massive extreme temperature rise. And third, that intense heat produces plasma, which naturally emits that famous blue glow. Understanding exactly how these 3 steps link together, ionization, heat, plasma, gives you the complete technical picture of this absolutely incredible phenomena. It really makes you wonder, doesn't it? If the simple act of electricity escaping its path and traveling through the air can create a superheated plasma display right in front of us, what other invisible forces are constantly shaping the physical world, just waiting to be understood? Thank you so much for joining me to unpack this fascinating technical mystery today. I'd absolutely love to hear your thoughts. So if you've ever witnessed an electric arc up close, let me know all about it in the comments.